So in our previous video, we looked at how we name ionic compounds. Today we're going to be talking about how we name covalent compounds, because we do have a different system for those. So when we were dealing with ionic compounds, we saw that for any given combination of ions, they can only combine one way. If you combine a sodium ion with a chloride ion, it's always NaCl, because the charge has to add up to 0. But because covalent compounds don't involve charges, they don't have that restriction. So that means that in covalently bonded compounds, the same combination of elements can combine in multiple different ways. So for instance, hydrogen and oxygen bond covalently, and they can either form H2O or they can form H2O2. Carbon and oxygen also bond covalently, since they're both nonmetals, and can form either CO or CO2. Sulfur and fluorine can form SF2, SF4, or SF6. Nitrogen and oxygen have a whole bunch of different combinations: NO, NO2, N2O, N2O4, N2O5, and there might be more. So we can see that there are lots of different ways for the same combination of elements to combine covalently. So that means that when we're naming covalent compounds, we need to somehow specify which combination we're talking about. So we're going to need to specify how many atoms of each element are present in the compound. So in order to name a covalent compound, similarly to what we did for ionic compounds, we're going to name the elements in the order that they're listed in the formula. And the last element named is going to have its ending changed to "ide." That same IDE ending we were using for anions just gets thrown on whatever element is listed last. And to indicate how many atoms of that element are present, we're going to add a prefix to the beginning of the element name for each element in our molecule. So our prefixes for 1 through 10 are listed here: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. One note is that we don't put the prefix mono on the first element in the name. So we're only going to be dealing with compounds that have 2 elements in them. So if you have one atom of the first element listed, you just say the element name, you don't put a prefix on it at all. If you have one atom of the second element listed, you put the mono prefix on the beginning of it, and we'll see that in the examples that we're going to do. So let's try this out with some of the examples that we talked about up here, so we can see how we differentiate between different compounds containing the same elements. So we're going to do a handful of these. Leave our rules up here. So we're going to list the elements in the order they're listed in the formula. So for H2O, we'll have hydrogen followed by oxygen, and we're going to change the ending of oxygen to "ide. So we'll have hydrogen, oxide, but we need to add in these prefixes to indicate how many of each. So we have 2 hydrogen atoms. Remember that our prefix is always referring to our subscript is always referring to the element before it. So the 2 is talking about how many hydrogens there are. So that means we're going to put the prefix di in front of hydrogen. So the systematic name for H2O is dihydrogen. And then we have 1 oxygen atom. It's not the first element, it's the second, so we will include that mono prefix. So we have dihydrogen monoxide is the systematic name for water. Nobody really calls it that. Water is considered its official name, but if we apply the same rules, the same system to it, dihydrogen monoxide is what you get. So if we compare that to H2O2, commonly known as hydrogen peroxide, the difference is that we have 2 oxygen atoms instead of 1. So we still have 2 hydrogens. So we'll start out again with dihydrogen. But now to specify that we have 2 oxygen atoms, this is dioxide. So this one is dihydrogen dioxide. Water was dihydrogen monoxide. So even though we're combining the same elements, the name allows us to differentiate between the two. So we also have CO and CO2, which are things you may likely already know the names for. But now you can actually see where those names come from and how they fit into the system. So both of these are compounds between carbon and oxygen. We have one carbon atom present in each of them. So one is the prefix mono, but we do not include the prefix mono on the first element in the name. So we're not going to say monocarbon. We're just going to say carbon. We leave that prefix off, just the mono prefix off, when we have only one of that first element. So then oxygen, we have one here and two here. So the first one is carbon monoxide, and the second one is carbon dioxide. So why don't you pause the video here and take a few minutes to try and apply the same naming rules to the examples we gave for nitrogen and oxygen compounds. So for these, we're combining nitrogen and oxygen in a bunch of different ways. So we're just going to be adjusting our prefixes to specify which of these compounds we're talking about. So in the first one, we have one nitrogen and one oxygen. Remember, we leave that mono off of the first element, so it's just nitrogen, but we include the mono on the second one. So this is nitrogen monoxide. Similarly for the second one nitrogen atom, but now we have two oxygens. So this is nitrogen dioxide. For the third one, we now have two nitrogen atoms, so we're going to specify that by including the prefix di in front of nitrogen, and only one oxygen, so we use the prefix mono. So N2O would be called dinitrogen monoxide. For N2O4, we still have two nitrogens, so we include that prefix di. And now we have four oxygens, so we use the prefix tetra to get tetroxide. So note that sometimes you'll drop an extra vowel when you're adding the prefix, so it's not tetraoxide, it's just tetroxide. Again, don't worry too much about the specifics of that. It's something that you kind of get a feel for, and it's really just about what sounds right, what sounds not weird. So I wouldn't worry about that too much at this point, but just something to be aware of, that sometimes an extra vowel gets dropped. Similarly, for all of these monoxides that we've been doing, it's not monooxide, it's just monoxide. So again, you'll get a feel for it. As you use it more and more and hear the names more and more, you'll start to understand what sounds normal and what sounds weird. But there aren't any hard and fast rules that I can really give you. And then for the last one, two nitrogens again is going to be dinitrogen. And then five oxygens uses the prefix penta. Drop that A to make it sound a little nicer, so we get dinitrogen pentoxide.